What's the name of your lab?
Our name of the lab is called Environmental and Health Impact Assessment Laboratory.
Can you briefly introduce about your lab?
So the focus of our research is to use a technique called mercury stable isotopes to understand sources as well as biogeochemical processes for mercury in the natural environment. So when we refer to mercury, people normally think of fish, and that's because humans are primarily exposed to mercury through fish and rice consumption, which are both stable food for the global population. But there's way more to mercury than just fish consumption, obviously. There are multiple characteristics that makes mercury both very unique in the environment as well as a global pollutant. Most well-known feature of mercury is that it is emitted into the natural environment through diverse anthropogenic activities, including coal combustion, waste incineration, as well as smelting processes. The other factor that makes mercury very interesting is that it is the only heavy metal that can exist as volatile phases in the natural environment. So basically, once mercury is emitted, it can travel in the atmosphere for in a very stable form for 2 years and deposit to even remote regions such as the Arctic. And that can lead to a lot of these controversial environmental justice issues. And that's one of the ways in which that makes mercury a very controversial as well as socially and politically interesting element. The other factor is that there is an international governance on mercury known as the Minamata Convention on Mercury. So it's a multilateral agreement to regulate mercury on a global basis by forming these international policies.
What is your current research interest?
So in addition to solving this global mercury problem, something that I'm very interested in nowadays is identifying sources and biogeochemical processes that are responsible for mercury exposure to our open ocean fish. And that basically boils down to understanding what's happening in our coastal systems or nearshore environment. So nearshore environment is extremely unique environment such that it connects between terrestrial as well as the open ocean systems. There is rich biodiversity and it provides a lot of ecosystem services. In addition to that, from the perspective of South Korea, there are a lot of local emissions releases that are introducing mercury into the coastal system. We also have a very, I would say, dangerous issue of substantially having a large amount of transboundary transport of mercury from the other surrounding Asian countries. And this is a very highly understudied field. So understanding the sources that are being introduced to our coastal system and what kind of environmental processes are driving the toxicity of mercury as well as the transport to the open ocean is something that we're hoping to delve into further.
What's the implication of your research?
The implication of our research is the fact that every scientific effort that is dedicated towards solving this mercury problem is in the support for informing better national, regional, as well as global mercury policies, especially in support for this Minamata Convention on Mercury. So everything that we do basically aligns with the major objectives of the Minamata Convention, which is to mitigate both ecosystem and human exposures for mercury. This international convention includes multiple articles that are specific to regulating anthropogenic releases and emissions of mercury. And one of the important goals here is to make sure that we can identify the sources that are subject to regulation by the Minamata Convention and be able to identify an important signal that there is indeed a reduction of these sources in the natural environment. In that aspect, we are using science-driven studies to better inform as well as evaluate the effectiveness of the Minamata Convention.
Is there any condition of the research success?
The major condition or criteria for success, I would say, is to be able to continuously integrate multiple scientific approaches and develop new methodological approaches to understand or precisely identify mercury sources in the environment. So in this regard, we use really diverse techniques. So in addition to the analysis of mercury stable isotopes in natural samples, we also incorporate modeling studies. We also conduct a lot of laboratory experiments, both in the field and as well as in the lab, in order to gain very controlled environmental understanding from diverse ecosystems.
Is there an economical or environmental expectation effectiveness to bring the success of research?
So I hate to say when I first heard this question is a lot of what we do have very little economic benefit, to be honest. I think what we do has more of a public health perspective benefits as well as policy benefits. In this regard, everything that we do in science boils down to a single question, which is to what extent can the science-driven policy, especially across this greater Asia, because we are the #1 emitting sources or countries for mercury. So how can the science-driven policy lead to effective reduction in mercury levels in both fish as well as humans?
What would you like to say to the incoming students?
Something that I want to tell my students, especially who are interested in applying to our department, is to have a really broad perspectives and holistic views on environmental sciences. So a lot of what we do is not just focused on developing new techniques or delving into science, but everything that we do have responsibilities and consequences to policies, socioeconomy, and there are also overlapping fields with climate change and other controversial issues related to the environmental science. So as long as you have a really broad perspective and know how to integrate multiple issues that are happening in the environment, I think that would be the key to a success and to keep your excitement and interest in environmental science.